The ozone layer. The ozone hole, the ozone hoax, pollution, skin cancer. The topic of ozone makes headlines on a regular basis, but why does a single molecule merit such media coverage? How important is the ozone in our atmosphere, and why are scientists so concerned about its increase near the surface of the Earth and its disappearance higher up in the atmosphere? First things first, what is ozone? Ozone is made of 3 oxygen atoms, O3. The oxygen we find in our atmosphere is made up of 2 oxygen atoms, O2. Because of its chemical structure, a single atom of oxygen is unstable. That is, it wants to combine with something else. That is why oxygen is almost always found in pairs, in its O2 diatomic form, where it is more stable. Ozone, O3, is less stable than O2 because it wants to return to the diatomic state by giving up an oxygen atom. When enough ozone molecules are present, it forms a pale blue gas. It is an unstable molecule that readily combines with other atoms. Ozone has the same chemical structure whether it is found in the stratosphere or troposphere. Where we find ozone in the atmosphere determines whether we consider it to be Dr. Jekyll or Mr. Hyde. In the troposphere, the ground level or bad ozone is an air pollutant that damages human health, vegetation, and many common materials. It is a key ingredient of urban smog. But in the stratosphere, we find good ozone that protects life on Earth from the harmful effects of the sun's ultraviolet rays. To understand how ozone is generated and the functions it serves on the Earth's atmosphere, it is important to know something about the electromagnetic spectrum, the energy emitted from the sun. Electromagnetic energy is sometimes described as traveling in waves and sometimes as traveling in packets of energy, referred to as photons. Progressing from short wavelengths to longer wavelengths, scientists have identified gamma rays, X-rays, ultraviolet or UV radiation, visible light, infrared radiation, known as heat, microwaves, and radio waves. Short wavelengths have more energy per photon than long wavelengths. Therefore, UV light carries more energy than visible light. Ozone is constantly being formed in the Earth's atmosphere by the action of the sun's ultraviolet radiation on oxygen molecules. Ultraviolet light splits up the molecules by breaking the bonds between the atoms. A highly reactive free oxygen atom then collides with another oxygen molecule to form an ozone molecule. But because ozone is unstable, ultraviolet light quickly breaks it up and the process begins all over again.